Hi guys, in this video we're going to be doing a simple experiment that can tie into a couple of different topics within the curriculum. It works particularly well if you're doing stuff to do with the water cycle or weather, but it also works well when looking at solids, liquids and gases. Now, to do this experiment you'll need a bottle with a little bit of water in it. You'll need some sort of foot pump. I've only ever normally used just a normal football pump, but I wasn't able to find one in the PE cupboard today, so I got this thing. You'll also need a cork, just a regular cork from a wine bottle that you've drilled a hole through, and a needle for a football pump or something like that. Okay. Now, this is more of an illustration or a demonstration for a particular principle. It's not so much an experiment that you would get your whole class doing. So it's one that you as the teacher can stand up in front of your class and instead of just telling them a series of facts about states of matter and pressure and all the rest, you can actually demonstrate it. You can do a demonstration of it. So what this is demonstrating is it could be demonstrating a couple of things, but the main thing that this is demonstrating is that there's a relationship between the amount of pressure on a substance and the state of matter that that substance is in. So the more something is squeezed, the more likely it is to transition into a higher, a more solid state of matter. So if you take a gas and you compress it, if you squeeze it hard enough, it'll become a liquid. If you squeeze it even harder, it'll become a solid. They reckon in some exotic planets where there's enough gravitational pressure, there's probably actually situations where you get water in a solid state even though it's warm, because it's being compressed so hard. It's not actually a liquid anymore. It's being squeezed into a solid, but it's not cold because it's being kept at a higher temperature. So you can get some fairly odd situations. We're used to temperature changing the state of matter, but this illustrates that pressure can do it as well. So all we're going to do, we're going to try and turn at least some of the liquid in this bottle, probably not all of it. We're going to try and turn it into a gas. We're going to do that by putting the cork in as far as we can and starting to pressurize it. Now I think this one's a bit more dangerous than my usual one. Eventually the cork should pop out, and there we go. So a cloud in a bottle. So what happened here is that we were compressing the gas, we were compressing the liquid, but then when that was released, the pressure was released so quickly that there was actually a negative pressure from the water's perspective, and then it evaporated immediately into vapor. So we were transitioning from a liquid state into a gaseous state there. And we can see that that's settled back down fairly quickly. But this is basically a small scale version of what goes on globally. So you hear about meteorologists, weather people on the TV talking about pressure fronts creeping in, and there's changes from high pressure to low pressure, and that affects the amount of precipitation, the amount of rain that we get. Well, that's what's going on in this bottle. We have something moving from high pressure into low pressure, and that causes a change in state of the matter. And when that happens globally, we get weather phenomena. So it demonstrates a little bit about weather, about cloud formation, about precipitation, on a small scale example, but it also demonstrates that not only does temperature affect the state of matter, but pressure does as well. Incidentally, something I forgot to say about this experiment is this is a principle that everyone who drives relies on in their car to get around from day to day, because it's this process of compressing a liquid, transitioning it to a gas, and then combusting it that fuels our cars. So this has real world application as well. Now, it's just an interesting teaching point to put in there for the kids. Cheers.